I'll let you know. Okay. So, hello everybody. Hope you all are doing well. My name is Shreya and I'm a senior program manager at Skillenza. Thank you so much for joining the Decult webinar on microservices design patterns with Spring Cloud. Decult is an initiative by Altimetrik. First off, let me introduce the team from Altimetrik who would be running the entire show today. We have Ms. Pooja Anurag Gupta, partner, innovation and industry engagement at Altimetrik, who would be the host of today's TCult webinar. I would also like to welcome our esteemed guest speaker, Mr. Anil Alevar, a senior engineer leader at Altimetrik. Thank you so much, Pooja and Anil, for joining us.
Thank you so much, Shreya. A very good evening, everyone. I will wait for more people to join in before we start. Sorry.
Yeah, so Pooja, we have started. So I think before we get started, let me just give a quick intro about Skillenza. So
Sure.
Skillenza is a 5-year-old startup, and we provide a platform for organizations to host various hackathons and challenges such as programming challenges, machine learning, data science, and full stack, etc. So we have a pool of 7 lakh plus developers who take part in these challenges and upskill themselves. Our main objective is to provide a robust platform for organizations to engage with these developers, ultimately uh, uh, resulting in the branding of the organization. So, alongside hackathons, we also host meetups, webinars, and
Uh,
other challenges.
Shreya, just a minute. Shrini, your teams, I think you should join the YouTube link that I have shared. Yes, Smita, you and Shrini both please join the YouTube link. I have just now shared through Innovate ID. Yeah. Sorry, Shreya. There's a bit of a confusion.
No problem, Pooja. I think that's about it about Skillenza. So, I'll hand over the show to you now. Over to you.
Thank you so much, Shreya. Very warm welcome and a very good evening to everyone. And I'm happy to welcome you all to our today's Decult session. Decult is our industry engagement platform for Altimetric. It's our registered brand and platform for Altimetric, where we host our tech talks. And for the external audience, we connect with external tech communities. Whether it is virtual or face to face, we conduct all our industry engagement events under the banner of Decult. Today, I'm happy to host this session on microservices, and we have our speaker, Anil Alevar from Altimetrik. I'll give a brief intro of Anil here. Anil comes with around 18 years experience working both with startups and enterprise IT organizations, focusing on nurturing and building products using lean startup principles. Prior to his current role, he worked as a CTO in a healthcare startup, solving the unique challenges of OPD appointments in developing countries to ensure patients reach the OPD just in time for their appointments. Anil has architectured, designed, and collaborated with the team to implement horizontally scalable performance products applications that leverage distributed systems, microservices, cloud computing, Java Enterprise, mobility, and web based single page applications. In his current role, he works with Fortune 50 customers to drive their digital transformation with emphasis on domain driven design, microservices, NoSQL, and DevOps. Anil has written blogs on microservices paradigm and spoken at multiple webinars. He's also contributed to open source projects in OData, Rancher, and REST and loves to explore and evangelize new technologies. Over to you, Anil. I'm happy to open today's session on microservices.
Thanks, Pooja. Thanks a lot, and warm welcome to all of you. So, kind of moving forward, I just wanted to kind of set up the agenda. So, we look at what are microservices really. We look at kind of what are the guiding principles that define microservices, and we'll look into design patterns. We'll kind of quickly interject demos in between, and then try to kind of strengthen the understanding of how things work, and then we'll take questions at the end, right? So, uh, Just from a guideline perspective, this meetup is for learning discussion. So please feel free to ask questions somewhere between or put that in the chat window so that we kind of get that moderated. We try to answer questions as they come along, so it's much better from a context perspective. But in case we are running behind schedule, I would just push that forward to the end of the talk. But nevertheless, just feel free to ask questions. We definitely want this to be as interactive as we can, right? Secondly, we'll do live demo and Murphy's laws apply. So something would go wrong, right? So please be patient if we run into glitches, right? Again, just for everybody's convenience, please keep your devices on mute unless you are asking questions. And then thirdly, all the code for this demo is available on public GitHub, and you can just go there and then look into that code as needed. Okay. Just some of the things to kind of ensure we have a good, fun, productive webinar. All right. So moving forward, I think we kind of heard the buzzwords microservices, but kind of I mean, this is a good diagram that I found that kind of illustrates what microservices are, right? So typically, if you see the first part, it's a spaghetti, and I'm sure for those of you who've eaten Italian cuisine and have kind of have had spaghetti or Maggie, if you just look into that, right? Everything is interconnected. You don't know what kind of is leading where, right? So that's how the monolithic systems kind of evolved over a period of time. They were tightly coupled, right? Everything kind of touched everything else. So if you had to make change, you have to kind of do all of them together and ensure that if you change something, you're not stepping on somebody else's shoes, right? So over a period of time, as systems underwent a lot of change, right? They matured, right? The spaghetti becomes more convoluted, right? And then making changes by itself takes a humongous effort. So I think that's the problem that came up with. So and kind of that's kind of what evolved. Uh, and then we came to kind of a service-oriented architecture, wherein you kind of define services, right? And then you kind of communicated through them through enterprise integration patterns. Like you could do that through services that basically send messages to each other, or you would have an endpoint such as an FTP that you kind of picked messages from and started the flow, right? But this was essentially asynchronous, right? So it allowed you to make changes to individual pieces and do that, but then all of that has to be kind of carefully altered because the contract was not explicit. So you had to go there and then ensure everybody understood what you are making changes and do that, right? And SOA is not new. It's, I mean, Linux has been having SOA and loose coupling, a principle of microservices, which is to do one thing and do things well from like 1970s, right? It's just that the underlying software ecosystem was not mature enough to kind of take this distributed system design to the software as a product, right? I think that's where around 2014, 2015 we kind of started getting. Once Netflix kind of came and then kind of they had their own ecosystem deployed and they outsourced it. That's kind of when the world kind of really got to know of a mature system which could handle distributed system in a better way, right? So that's kind of where you had the Netflix open source component and appropriate components there that kind of came in and that tackled the distributed system design problems in a fairly intuitive and stable way, right? So that's kind of where microservices really came into mainstream, right? So kind of the crux of microservices would be you create independent services that you develop and deploy independently, and they are linked through a shared, either it could be an synchronous API calls, or you could also share data through async mechanism, could be a message queue, or could be an event driven architecture, right? So that's kind of where we evolved from the monolith to microservices architecture. So a lot of people just move to a microservice for the sake of it, but it's not an easy shift, right? You do have to consider, because any distributed system comes with its own unique set of challenges. But that's an overall architecture, right? Okay. As I said, please interject anytime you have any questions, or type it in a chat and we'll take it. Pooja is kind of moderating that, so we'll take questions that are relevant, or we'll take all of them at the end as it progresses. Right. Now, what is it that we are looking for when we say, or everybody is clamoring for the microservices bandwagon? What does microservices offer you, right? It offers you, first of all, scalability, the ability to scale up horizontally by cloning, which is what Monolith also kind of enabled you to do. But then the problem with Monolith was you had to clone everything together, right? So if you had only one component that needed scaling, assume you had a payment processor in which you get a lot of transactions, right? But if you had a monolith, you had to scale up that whole system. So you basically put in more resources for authorization and account balances and all, but you really needed more resources for transactions. But then, I mean, you had a huge waste of resources. So while that cloning was available with it, we're able to scale up what is really needed. So that's part one, right? And then we're able to vertically scale up by doing a functional decomposition, and that way. So if you really look into the cube scaling paradigm, right, where you kind of we're trying to achieve an infinite scale, you get an x, y, and z axis. So you kind of, if you do all three together, you can really have an infinite scale. So the horizontal cloning in the x-axis, the vertical cloning, which is actually where microservices shine, is the y-axis, and then you actually can break down your data and the way it's accessed based on, let's say, each customer characteristic. So you really do sharding of the data to kind of ensure that only some data is available to some specific user. So once you do that, that kind of becomes the z-axis of your scale cube, and that's where if you have all of this three together, you can really go to an infinite scale. But I mean, infinite scale is a metaphor. You really, for a lot of the things, you really don't want an infinite scale. You want the ability to scale up and down as per demand, right? So if you're able to scale up and then you're able to scale vertically, that should serve most applications that are there, right? The second thing that really kind of appealed also to business and developers is faster time to market, because you could have independent development and everybody is not waiting for somebody else to finish, right? The third thing that all good software system in kind of, you would say, enforce is cohesion. So you have one, so this service will do one thing and it will do it well, and it kind of exposes a set of APIs that makes interaction with it easier. So that's the third part, right? Then what you're looking into is resiliency, wherein you recover gracefully from error. Sorry, right? Both during startup and crashes. So if you really don't want your service to start for certain things, then you should have the service crash at startup. But if you really have, let's say, a database connection that you want to check, then you could put in a periodic block which could check if the database connectivity is up or not. So there are different paradigms that you could kind of look into resiliency, but definitely you should have resiliency during startup crashes, right? And then kind of be able to have a stateless service that is able to take care from there. Then inherently with all distributed systems, which microservices, you will have thousands of microservices for certain large production systems, right? So monitoring is mandatory, so that you are able to monitor and auto recover. If you use microservices in connection with containers and orchestration tools like Kubernetes, kind of that's kind of where your auto recovery works well, and you're able to kind of check whether my service is running or not and get it to restart, right? And then, as with kind of breaking this, your monolith and multiple systems, you need DevOps and automation. Without that, your microservices are not going to take you anywhere, right? So you need the ability to kind of have a continuous integration and a continuous development for code deployments, having a shift left approach wherein you do your testing early in the cycle, right? So you don't get surprises at the end. And then obviously you once you kind of go into infra as a code kind of an paradigm, you also want the ability to auto scale both at an infra and service level based on bursts that you see on the traffic. Okay, so that's the core guiding goals of kind of microservices. We'll kind of now jump into the design patterns, right? So I'm sure you would have kind of obviously heard microservices in conjunction with domain-driven design, right? So that basically is a decomposition how we kind of take a monolith or we take a business context or a business boundary and say how does it map to the real life world, right? How do we create what is called an ubiquitous language, which is a language that everybody understands, let's say, what an order is about, right? So that becomes a domain. So you kind of look into all of this, you work with business to kind of look into, okay, what comes in, what happens in, and what moves out, which we call as event storming, right? And based on that, you kind of come up at a broad level. What are different types of domains? So when you look into domain-driven design, you ideally should come up with three different kinds of domains. There are core domains that are fundamental to the business, right? Without which, if you look into Swiggy, food delivery is a fundamental domain, right? Payment is a fundamental domain, right? Something to that effect. Like the supporting domain would be something that is not a business differentiator for you, right? So if you look into notifications you get on Swiggy, that's not a core domain, right? Or kind of you would say restaurant reviews, right? While reviews are tied to us, they help an end user basically make a more informed choice about the restaurant. It's not a core business differentiator for, let's say, a food delivery service like Swiggy, wherein their core model is how do I deliver food, right? So that becomes your supporting domain. Then generic domains are technical domains that you basically help you to do things that are not tied to the business, but they perform more at technical functionality. So I think we already talked about notifications as a generic domain, right? You could have an authentication layer that could be a generic domain. So when you take this up, I think this is more from architects and kind of tech leads scenario who'll kind of really get into this, right? Or a technical product managers. But I still wanted to let you know that this is critical for you to define microservices or kind of start doing microservices. Unless you have a good domain-driven design, you will create a distributed monolith, for lack of a better word. It still is a ball of mud, right? Now, once you create your domain design, you'll take each of those domains and then apply what I call as tactical domain-driven design to kind of take that domain and bring it down into say, what are the actual microservices that you would need that would kind of serve the domain objectives, right? So we start defining an entity which is a unique, some data that kind of has to be pursued in a unique identity, right? So something like in the case of a food delivery service, a restaurant could be a unique identity, right? A user's orders could be unique identity that has to be persisted, right? So that becomes an entity, right? So you basically take a user and he would have accounts, and then you would have maybe his preferences, right, and all of that. Now, at that broad level, a user is what you are tracking. That is what your entity would be, and then you would have other entities that fall. So within the tactical domain-driven design, we call them a root entity and then child entities. And you could have value objects that are not dependent on entity but store additional attributes. I mean, just as an example, you could have reviews written by a user, right? That don't need a unique identity. So all of this together, when we take the corresponding root entity and its corresponding, you would say entities and value object, these are a candidate. This is what we call as an aggregate, and that becomes a candidate for a microservice, right? I mean, this is a whole 1 hour, 2 hour session that we could do on this separately. So just at a broad level, I just wanted to touch upon how we do decomposition, so you are aware as to when I'm creating microservices, how they should be defined, or what's the process to reach to the definition of a microservice. Again, any questions on this? Okay.
Amit, sorry, Anil, yes. First is, I guess you will be taking some demo after this theory session. The people are asking for
I'll
that.
try to I'll try to interject the demo in between the in between the theory session so that it's more fun.
Okay. Okay. And
Okay.
there's one question. Would you
Sure.
like to take now or you want to take later?
I mean, that's fine. Let's just give that a try now.
Okay. So the question is, how do we differentiate the supporting domain versus generic domain?
Okay. Supporting domain is something that is inherent to the business, right? That's still part of the business. So like I said, reviews, let's say if you're taking a food delivery app and you are creating reviews for a restaurant, right? Those reviews by itself might be a different domain based on how the business, so it supports the main business, right, in terms of doing the food delivery, but by itself it's not your business differentiator. That's not what Swiggy or Zomato is known for, right? They're not known for reviews. They're known for doing food delivery. So that is your supporting domain, something that is tied to the business, but it's not your business differentiator, right? A generic domain will almost invariably be a technical separation, like schedulers, or like I said, notifications and authentication authorization layer. So that's something that is common, but it's almost entirely technical. Okay.
Okay. There's one more.
Sure.
think DDD is the first step in designing a microservice, isn't it?
It is always, see, at the end of the day, technology is there to solve business problem. So if you don't understand the business well, you cannot solve that problem, right? So when you are looking at creating microservices, you have to start with the domain-driven design to understand what the domains are, right? So otherwise, if you end up doing your domains wrong, then you would basically plug in. You'll have a lot of interdependencies. You'll not really have truly independent, loosely coupled services. So domain-driven design has to be done and done well for you to kind of arrive at the microservices that you would like to deploy.
No
Okay.
more questions. Yeah,
Sure.
for
So
now.
I think from a deployment, again, we'll go on this very, very briefly, right? So there are two different things that, yeah, I mean, when you do a greenfield deployment, right, and you're starting fresh, obviously microservices, I would suggest, are not the best choice if you're just starting a new product, right? Because you don't know the domain, you don't know what's going to come up, how things are going to relate, and that's going to evolve based on your customer feedback. So I always suggest to startups or people who are starting their product first to go with a monolith, right? Do a modular monolith, and that will give you speed and flexibility to do that. But if you had a monolith, let's say, and you've done it in Python, whatever, for kind of starting it, or you want to really kind of say, now that I'm at a stage where I'm at 100K users, I want to really scale up and build this from scratch, then microservices becomes a good choice, right? Wherein you do a greenfield development, you take everything from scratch, you know your business, you do DDD and then break it down into services and start. But 99% of the time that doesn't happen, right? For large enterprises that want to move to microservices, you will always have your existing legacy that has to be supported because that's where your business. And then kind of porting that to microservices is going to take a significant amount of time. And this is kind of what we call as brownfield development, right? Where things are going to coexist. You're trying to take something that already exists and trying to break it down and then build a set of services for it, right? So for that, what we say is your strangler pattern is your best bet, wherein we kind of transform, create your service, have them coexist together, and then we basically, once your new system is stable, you eliminate the legacy. It's what is called as strangle. So if you basically look into a creeper that kind of just goes around a small tree, right? At some time that the creeper will take over and it strangles the tree. That's kind of where that pattern name came from, a strangler, right? So where you squeeze and squeeze that monolith and then you eventually move it out, right? So if you take that as a pattern, right, you'll basically kind of create a facade that lets you redirect
Breaking
requests either to your
in
uh,
between, there is some network issue, I guess.
okay, can
It's better now, but in between, like after every 10 minutes, it kind of break for that.
yeah, I'm apologies on behalf of my network
Again,
service
it's
provider.
breaking. I don't know. It's my. I don't think it's my network. Shreya, you can
Okay.
hear Anil properly?
Uh, no, Pooja. I mean, I think in between we are losing
Shreya,
an
are
edge.
you okay? You can hear Anil properly? Or you also experiencing the
Okay,
glitch?
I'm going to stop my videos camera for a while. I hope that helps. Okay.
Yeah, that would
Yeah, give
help.
me one.
Okay. And I'm going to stop the screen sharing and I'm going to
No,
share. Pucha, can you hear me better? Hello.
Yeah, Anil. Yeah, I could hear you fine.
Okay. All right. So we'll just kind of we'll continue and then hopefully Puja can catch up. Okay.
Yes, sure. Please continue.
Okay. Just interject me if you feel there are like any issues with the network or bandwidth. Okay.
Yes.
All right. So like I said, when we kind of want to kind of have them coexist, you kind of create a facade that lets you redirect traffic either to your legacy or to new one, right? Then you deploy part of your services into your microservices, and it can interact with legacy for backend information. And you slowly port your functionality from legacy to microservices, right? Now, once all the functionality is ported and it's stable, you basically kind of just have the switch bypass the strangler facade and then kind of take the request only to microservices, and then you just strangle and take the whole legacy application away. So now this becomes your primary source of truth, and that's kind of how it works, right? So that's the strangler pattern from a decomposition and deployment perspective, right? Similarly, with a lot of new service meshes that are coming up that tied intrinsically into Docker and Kubernetes, you have an infra layer within your architecture that just plugs in as a sidecar, like you had a sidecar for a scooter earlier, right? That's how that name came into being, right? So you don't have to kind of make any changes to your code. You just basically have the sidecar proxy injected through that engine, and it takes care of different infra related stuff for you, which is controlling traffic flow, service discovery, right? Mutual SSL between services, and all of that, right? So I'm going to quickly brush through. Then I think let's look into common cross-cutting concerns, right? So there are certain common patterns that are used in all microservices. One, if you go into 12-factor auths, the first is the external configuration, where you externalize all the config based on environment. You can use, and then those could be maintained on GitHub, or if you're using Kubernetes, you could also use Kubernetes config maps to do that, right? And then within the Spring Cloud ecosystem, you can use a Spring Cloud bus to dynamically update these properties for beans that are annotated with configuration properties and refresh scope. Then you have service discovery. So part of the problems with distributed system was, how do I know? Because systems could come up, systems could go down. What is an ephemeral way for me, or so that I can just kind of call an endpoint, and it basically forwards me to the correct corresponding service. I don't have to worry about where that is. I don't have to know the physical endpoint, right? So that's kind of where service discovery came into picture, which kind of follows a cloud native architecture to isolate that tight coupling to service. You don't have to know where it's deployed, right? Then similarly, you have circuit breakers. So typically when each services call each other, they might break, right? And this failure kind of cascades, right? So what you really want to do is, if you what you want to do is, like, you have a circuit breaker in your electricity board. When your failure crosses a threshold, that circuit just trips, right? So the circuit breaker says, I'm no longer going to send this request to my end service. I'm going to kind of sending either an error or a default response during a timeout period, right? Once the timeout period gets over, the next request will go to that service again, and if that's up, you basically start receiving data from that service, or otherwise your circuit will kind of trip again. So that's the circuit breaker pattern that you would use. Then you also need to have a security at each API layer, right? So you could use a security schema like OAuth 2 and JSON Web Token to propagate the user authentication. So we'll take a break here, and we'll try to see if we'll try to look into some code. Okay, give me a minute. I'm going to share my screen. Okay, all right. Let me know if you're able to see my see an item terminal window. Okay, I assume
Yeah,
yes.
Yes, Anand.
we can see that.
Okay, all right. And this is the code base, like I said, that's available there. So what we're really basically going to look into first, an externalization configuration engine. For some reason, my Mac is also behaving not in the right way. Okay. So for an example sake, I have my configuration set up on a public cloud repository. Okay. So this is where this configuration is. If you go back to GitHub, and then we kind of go back to that specific repository, this basically has the configuration for each of those applications that we basically will spin up. So let's assume, say, if I spin up my service registry, which is the discovery, it tells it, instruct it to run on port 8761, to say that my host name is going to be localhost, and then I don't want
Anil,
you
can
to.
we zoom it?
Sure.
I think people are not able to see it.
Sure.
We're asking for zoom.
Is this better?
I think yes. Further zoom, is it possible? Is it possible to increase the screen size? I think I'm not sure.
Not the screen size.
Okay.
I'm kind of
I
relaying this
hope
from a
it's better
laptop.
now. Abhishek, Swapnil, I hope it's better now for you. I can see at least.
Okay, good. We'll just go with that then, right? And this is kind of you could again based on Spring profiles you can override that for a different kind of profile to say okay have a different host name. So you see here the host name is different, right? And you could kind of have some of those could be repeated. So if you go back, let's say similarly for some other microservice, let's say we just take the task web service as an example. Again we're saying run on a different port, right? Which is my where is my Eureka client running, which is our service registry, right? And then over here you would basically see for a Docker profile we specifically overridden that the base URL could be different, right? And then over here certain this would be different, and then if you see a port that I'm running on is different then I'm running it. So this is how this configuration gets ported automatically using that config server. Okay, so I'm just going to run the config server. So I just built it like before we started. Let's just pull up our web service registry. We basically see that it started on. I'll I'll try to kind of zoom in for a specific content, but I hope that people are able to at least see some of it. But I'll nevertheless try to zoom in a bit more. I hope you're able to see it. Pooja, can you just confirm?
Uh, Anil, we can see, but it's too tiny. I don't know whether I
Okay,
don't think it's readable for people. You can
okay.
see a
I
lot of
hope so it's better now.
little better. Yes, yes.
To just zoom in
There
and
are
then
some
we'll go back.
questions also, Anil. Let me know when I can take those.
Sure, sure. I'll just kind of show that we're fetching the config server from there, and then you'll actually see that we located that property source to come from your GitHub repo, right? And that's how we basically got our server to run port 8761. Okay. So while I reduce this, we can go ahead with the question, Pooja.
Okay. So one of the question is how we take care of data migration while transforming from monolith to microservices, mainly about critical user data or a transaction associated attributes in specific.
Okay. So there are two scenarios to that, right? When you look into the data migration, how is your data located, right? So for a certain client that we work with, we kind of have them use Oracle Golden Gate to kind of take their transactional data that they have and all the data that they have in Oracle, and then use data migration utility or a tool like Golden Gate to kind of port that data into JSON format, push it on Kafka, and then kind of ingest that on the other side. So you could have that data migration done one time as an initial load, but if your systems are going to running in parallel, you'll also have to cater for an incremental change. So that's how the data kind of has to be migrated. So again, like I said, it depends on what you're really using. Okay.
Okay. The another question is when both coexist, monolith and microservice, will data redundancy be a concern?
No, because your system of truth should be one single person. One. So if you kind of are going to have system on both sides, you need to have a bidirectional replication of data for your systems to be in sync. Did that make sense? Okay, so basically, if let's say you are having your account information, that your primary source of, let's say, data was your legacy is in Oracle, your target is in Mongo, right? So once you bring in the account information from Oracle to Mongo, right, your transactions might still be flowing in Oracle. So those have to be continuously getting moved back to Mongo. Similarly, once you your account functionality mature and Mongo basically becomes your primary data store, any account changes you make have to go back to Oracle so that any functionality that needs account data there can still use it. So that bidirectional data transfer is something that we still have to work on and get that to work. Okay.
Yeah. I think Vikram got the answer. We can move on. There's no more questions as of now.
Okay. So I'm just going to start a database for us to use our authorization server. So it did start. We'll try to start one of two services.
Okay. Shreya,
Yeah.
can we close the participant window from the left-hand side? I think uh, people are suggesting that can give them a bigger screen space.
Yes, sure. Pooja.
Third, we've seen a centralized configuration server and how that configuration flows in. Let's look at Eureka, which is our service registry, and see if whatever we have started, those services have registered to Eureka. So you've seen that we started these four services: the authorization server, the comment shared service, task, and user web service. So all of them kind of have registered to Eureka. So if you start another service, which I can't on my local host, obviously because there would be port conflict, right? But you could, if you have more than one service that basically is an instance of the same service, then all of them would basically appear here, right? So this is kind of where your centralized service registry comes into picture. We'll kind of look into the other parts of it, like I said, slightly later, as we kind of let's just look into some further thing, and then we'll kind of come back to the demo, I think, right at the end. Okay. So then quickly we'll bridge through database patterns. So as we move into microservices, they say that the ideal state is you have a database per service, but it depends. It's not always possible, specifically for brownfield deployments where you need to kind of have the data shared. So you could have, based on your use cases, you could look at using a shared database, right? And if you really need a very high throughput scalable system, you could look at event sourcing and CQRS, where CQRS is command query responsibility segregation, wherein your writes are different. Your write store is different from a read store, right? So when you write something, you kind of do a create, update, or delete operation from the CRUD methodology of making changes to any entity. You push that data into an event queue, so it basically becomes like an time sliced view of what different operations have happened. This gets stored into event store, and then the handler really kind of pushes them into a data store, right? And think of it that if I'm creating an order, you would have multiple things that happen, right? You kind of process, look into inventory, then you kind of then make payment and all that. So each of them become an event, and that could be pushed into an application data store to say, this is my payment information and this is my orders and all of that. So when you read, that read is from a different data. So this model kind of advocates eventual consistency, right? But this is a very highly scalable model if you really want to do distributed systems at scale. Okay. Then similarly, we talked about the chain micros, how microservices kind of communicate with each other. So three different ways that kind of happens. If you really are one obviously part is each API calls every other API, right? Either through a synchronous call, wait for it, or asynchronous using like reactive frameworks like RX Java or Spring Web Flux, right? And then each of those basically you make a call, wait for the response to come in, you kind of then aggregate all of it together and send that back. The other way is to do that is to kind of really have a message oriented stage management wherein everything. So if you have to place an order, right, I would kind of make a call to the payments API. The payments API will do certain things and then it will basically say that, okay, payment is confirmed, not confirmed. It will put that into the message queue. Then once if it's confirmed, the order system will pick it up and then it kind of confirm that the order are done. It pushes it back to the queue. Then the shipping system brings it, picks it up, right? Then it confirms on the shipping and then it keeps messaging back. So based on whether your payment is successful or not, you basically go back over this flow. So this the only challenge with this is some of your contracts are not explicit sometimes, right? So it's harder to kind of correlate it between distributed teams. So the third way for kind of you do the chaining of the microservices is using an event-driven state management, right? Wherein you use an event propagation bus, could be Kafka or could be an MQ like RabbitMQ, but then instead of kind of sending messages, you send events to say that order placed is an event, right? So once it comes to the event queue, it could be a common event queue. The payment system is interested in it, so it picks up that order placed thing. Then it says, okay, make a payment for it, right? It kind of sends that message back, make a payment, which gets picked up by the UI. So that is how it flows. So your event store is a single entity that kind of you can replay whatever happened, right? And asynchronous, everybody can pick up from that common bus and do what they would like to do, right? So this is a fairly mature, stable way of chaining microservices. Again, this is something that the architects and the enterprise architect, the technical architects designing that system would decide on what works best. But this is something where if you really want to do well-designed distributed system, this is where you should go to. Okay, then you would have an API gateway, right? Kind of, if you look into the APIs, how we want to kind of group them, uh, you would need to have a set of APIs that mimic what the user is trying to do. Like if he's placing an order or he's viewing at a dashboard, the data has to come in a single call and has to come consistently. So you need an experienced API layer that mimics what the user is doing, and then you typically have what we call as two more layers in your APIs, which are called a domain layer. A domain layer basically brings up a single business operation, and it's also responsible for rolling back if that business operation doesn't succeed. So right. So and then you have at the bottom you have a system set of system APIs that are very fine-grained API that do only one thing well, and you kind of really kind of call all of them together and compose your next two layers based on that, right? Now, but when you have all of these APIs in front, you need a common layer to front all the APIs, right? So basically, it proxies your request to all the concerned microservices, right? And it can kind of do other things, right? It can kind of act as an aggregator, right? To basically get data from multiple microservices and build it together in parallel sequence and give it back, right? You could have your API gateway, so that the API gateway provides all of this functionality, right? To kind of give you a single window or a single endpoint to call the services, and it manages the routing to all of this API endpoint, right? So you have different options like software gateways like Zool or Spring Cloud Gateway. That's part of the Spring Cloud framework. Then you could also use commercial third-party tools like Apache or Kong or IBM Cloud Gateway to set up your API gateway. But it takes care of like all the other common concerns like what we call as throttling, right? Or having a common authentication layer. Similarly, if you are making requests from the browser back to the API, you need a cross origin access, right? For somebody in domain A to make a call to domain B. If your APIs are hosted on a different subdomain or domain than your UI, so all of that is functionality is taken care by the API gateway. So that forms an integration pattern, and we'll look into that in a bit, right? Similarly, the other thing that comes into picture is how do you handle transaction, and that is one of the most difficult problems to solve in microservices. So my inherent advice is, as much as possible, keep your bounded context self-contained so that you don't have distributed transaction. But if you absolutely have to do distributed transaction, then we use what is called as a saga pattern, right? Which kind of basically says how do I kind of then handle a transaction across different. So you cannot really use traditional transaction distributed transaction pattern like two-phase commits and all, because your boundary is outside of a single JVM. It's not part of your single runnable instances, right? So again, within Saga, there are two different ways. You can have a choreography based Saga, wherein you send messages and that message decide what's something next that has to happen, right? So in this scenario, if I place an order, then I would basically send a message on the queue to saying reserve an inventory, right? And then it gets picked up by the inventory system. It would reserve inventory. If it reserved, it says, okay, I have enough. I can reserve the inventory. Go ahead and make a payment, right? So that payment request goes back, right? And then the payment basically could become a success or it could be a failure. So if the payment is a success, you correspondingly push a message out to say payment is successful, and it gets picked up by shipping. Could also be picked up to kind of tell the UI that the order has been accepted, right? But if the payment is failure, you would then do multiple steps with that. You would basically release your inventory. You would also cancel the order, right? Though, so what happens is all this communication happens by messages that you put on, let's say, your queues, and then based on that, the listener on the other side decide what I have to do that. That's one way to do that, right? The second is what is called as orchestrator based saga, wherein you have a single you would say an entity or a piece of code that handles all of this to say, okay, I'm going to basically send a message to reserve inventory. I'm going to decide what needs to happen next, right? If that reserve inventory is successful, then I'm going to make a call to payment, right? And do that. So it becomes a centralized way of orchestrating that saga. That's kind of why it's called an orchestrator, right? So this is what you will do. But then think of it this way, that all of that rollback and all is not going to be provided to you by the system or any database or whatever tools used. You have to do all of that on your own, right? So doing distributed transaction in microservices is a pain, and it will continue to remain a pain. So it's best to try to avoid them as much as we can. But if not, these are some of the patterns that you could use. Okay. Then we'll look into some of the patterns for observation and monitoring. You could have log aggregators. Typically, if you get this data, right, you would want to kind of look into all the logs from different services, and right, and we can analyze them. So you could use tags like ELK, EFK, which is Elasticsearch, Logstash, Kibana, or Elasticsearch, Fluentd, and Kibana, Amazon CloudWatch, or React to kind of get this logs aggregated, right? Then you will have to kind of monitor performance so that you know where your system is going wrong, whether it's short of resources or something is happening, maybe your index is not right, right? So you need to have tools like application monitoring, performance monitoring tool like App Dynamics, right? New Relic that can that have agents running on each of those services, and then they push data, so you can kind of trace that request and see how it kind of what time is taking it everywhere. You also have open source tools like Prometheus that pull data from the microservice and then store it into a time series database, so that you can kind of then again look into that and then see how it's behaving, right? The other monitoring thing that you need is you need to be find out if my microservice comes from, let's say, an API gateway, then it calls service A, then service A calls service B and service C. You want to be able to trace all of that together. That's kind of where you would need distributed tracing, right? To see a single logical request, in which case could be an API call, which we call as a trace, as it spans through multiple services, with each, you would say, execution within that service being a span. So your log should basically find out what my trace is, what my span is, so you can kind of do that, right? So this is really relevant if you're doing any chaining and aggregation, because without tracing in place, you cannot debug anything in production. You'll just not be able to, right? So that's something you should definitely add in. There are a lot of tools that have stable, matured now. From a distributed tracing, you could use Zipkin, Jagger, or AppDash, right? Similarly, when you kind of have distributed systems that are truly cloud native, that can go up and down as we need, you need to have health check to decide whether the service can accept request or not, right? And if it cannot accept request, you want to shut it down and bring up a new instance of it. This is done by specific endpoints called health check, right? And you could do that using Spring Actuator or socket-based Spring check, different ways to do that, right? And you would use an orchestrated tool like Kubernetes to kind of take that forward. So with that, I think let's just jump back to our demo, and I'll try to see if I can start the API gateway and then get that to.
Anil, can we take few questions before that, or
Sure,
you
sure.
want to take after that?
Yeah, let's go ahead. While I'm doing this, we can kind of take more questions.
Okay, one of the doubt is that why we use Fain client rather than REST template in case of microservice communication.
See, both of them solve the same problem, which is how do you do an inter-service communication. FinClan just makes it easier because you just define your set of interfaces, right, and then kind of tell it configure with configuration on what you want to call. So it makes it easier, but inherently it would still use a REST template, right? So FinClient is just an abstraction layer built on top of kind of a REST template or whatever system that you are using to make those calls. But essentially it's the same. It just is a much easier abstracted out way that somebody created to make your inter-service calls much more easier to make. If that's kind of, hope I that solves the, or was what the what he was
Question
looking for.
is,
Yeah.
I hope so. Moving to next question. Since API gateway is only one instance for say authentication, isn't that limits the scalability, and how do we overcome this?
Okay. You could scale out API gateways also, right? If you put a load balancer in front, right? If you go to an Amazon and put an application load balancer, so the way I would say is, let's assume that your API gateways are on the public domain, right? Or they could be on private domain based on how we do that. But if you create an AWS application load balancer, you would have an application load balancer that could then basically fan out the request to individual API gateways also. You could have instances of API gateways. And that's what you would do, because then again, you'll have a single point of failure. And then each of these API gateways get all the service register, and they kind of fan out the request accordingly. So yes, you can scale out at the API gateway, and then you can essentially you can have like a tree structure that you can scale up on at different levels.
Okay. And next question.
Sure.
Yeah, next question is, does Swiggy app follow event-driven state management?
We'll have to get somebody from Swiggy to do that. I cannot answer that as a question because I don't know. I don't know the internals of it. But it depends on your scalability requirements, like I said. Okay. It depends
Okay,
on what
next.
your scalability. If you really want a very high throughput scalable system, you would have to go with an event-driven architecture and eventual consistency. Okay,
Okay, next question.
sure. I
Yeah.
seem to have
How
run
to?
into certain issues. Good.
Oh, okay. So you want to fix that, or you want me to go ahead with the
Let's just
question?
go ahead. I don't know. This seems to be a network issue because it's not able to resolve probably. Good.
Okay. The next question is how to scale API gateway since all requests are handled by a single server, if I am not wrong.
No, no, you can. Like I just talked. I think this. I don't know if we kind of got a repeat question, but I just answered that you can scale out your API gateways as well. If you have a stateless microservices, right, where You don't really mention the state, and you kind of pass your authentication information using either a validated cookie or a JSON web token. Then you don't really need that, right? Give me a minute. This seems to be a network problem for me. So we'll look into this probably a bit. I don't know. Go ahead.
Okay.
Mhm.
The next question is like it starts with, as you mentioned, ideally each microservice should have separate schema for it. How does caching works in distributed system?
Okay. Again, you could have a distributed cache, right? And the distributed cache could be shared across all the microservices, and you could have a common utility that lets you access that cache, right? So if I really, let's say that for some reason I cannot use a JWT token to then pass my authentication information, and then you would say that, "Oh, for an authenticated user, I'll pass you a cookie, but all of that information of what the user is entitled to do, you might just plug it into a distributed cache and then have a common utility component that picks it from there." Did that make sense?
I guess so.
Okay.
Okay, next moving on to next question. What are the parameters to differentiate between methods to chain microservices?
Method to chain microservices. Okay, now that depends on your domains and how you've defined your microservices, right? If there are singular microservices that do need to, and that's going to be a fairly common scenario, right? Now it depends on certain things, right? So if the UI says I'll do something at, let's say, order processing, right? And if you can confirm that order that I have inventory reserved, maybe that needs a synchronous call to kind of do that right at that point of time and take it forward, right? But if I receive a payment, and that receiving of payment basically needs to do a lot of things, which is to kind of, you would say, confirm that reserve inventory, start shipping and all of that the user doesn't need to know. He only needs to know that the payment happened. So in which case you could go with an event driven architecture to kind of do all of this asynchronously on the background, right? So typical thumb of rule would be to say that if you need something really immediately, you go with a synchronous call. Okay. If you don't need that, then you could go with a asynchronous call. You could kind of then dump it in the background.
Okay. Chetan was asking for some examples in Flow, which I guess you already gave the examples while in your presentation. Uh,
Right.
Chetan, you let me know if you need any more examples. So I'll move on to the next question, which is orchestration based is kind of chain of command pattern. It's like it's a question.
Orchestration is a chain of command, but then yes, so if you really go with a command pattern and you would have a single, so the command pattern kind of follows a different paradigm in which your state is shared, right? And that state basically get passed to subsequent command. You again have an orchestrator that does that. Okay, give me a minute. I'm just trying to restart and see if not running into anything. Okay. So when you look into command pattern, you have the same thing. You have an orchestrator that does that, but your state is shared and it's an in-process call. So your commands are running in the same JVM or in the same process, and that's how they pass their information, right? But when we look into the orchestrator saga, because inherently your services are different, you would use either an MQ or a synchronous call to kind of do this. So it's more that state is not shared across all the commands. It basically is only specific to somebody that you are calling now. Okay, I know it's a slightly convoluted answer, but that's how it is.
Okay. Uh, Next question is how to handle rollback in Saga pattern.
Okay. Now that you, so for each event that you want to do, for each failure that you get, you need to have a corresponding functionality that can do the rollback, right? So let's assume, and let's take that example that we had, wherein I said place my order, right? You reserved an inventory, but then your payment failed. So we saw there that when it failed, that specific service put in another event to say reverse or release that inventory, right? So that's something you will have to do manually. Okay, and then you will have to kind of orchestrate all of this. That's kind of why I said that distributed transactions in microservices is not the right way to do it. You should avoid it as much as we can. Okay, and I
Okay.
have absolutely no idea why this is not working, but anyways, because it worked in the morning when I looked into it. Go ahead. We'll just try to kind of continue for now.
Yeah. Next question is, why more use of @fin client reduces the performance of a service?
Okay. It depends on, it's a very specific question. So unless we get into specifics of why it does that, it could also be because of the thread pool that your thin client is using. Because internally it uses a set of executor framework to kind of make those calls, right? So it could also be because of the number of parallel threads that you need to kind of make those calls. So you'll have to look into bumping up that executor. That's one part of it, right? And then it also depends on what is the object that you're passing. So if you are using, let's say, an OAuth to REST template to kind of pass that information, right? Then we'll have to kind of look into that and see uh, how uh, how that data is passed. Right? If you have too much of data and that's what is taking a lot of time, then that's what would also lead, because all of your threads are now busy. You don't have things in the that are available to take up more calls. It's similar to, like, so think of it that your fin client has a set of its own threads that it's basically doing that. So if you are running into issues kind of getting that to move forward, then you should definitely consider kind of looking into that executor framework and see if that you could kind of make it to, or make it go faster. Rather, sorry, increase the number of threads. Sorry, I'm trying to do this to get in parallel. So sometimes my thoughts just kind of go here and there.
I hope we got the answer. Now, next question: how to work messaging system in microservices?
It's
Messaging system.
basically
Yeah.
the way you would do with any asynchronous system, right? So you define a contract to say that if I'm going to put in an event, I'll put a JSON object onto queue, which basically has the command as, let's say, I'm sorry, which basically says, or you could put a header to say that basically says my command is order created, right? And then you could bring that in, and then each of your service could actually pick it. Either you could kind of put it to a specific, let's say, Kafka topic or an MQ, and only somebody who's entitled to listen that picks it up, or you could kind of have a common topic that everybody subscribes to. So it depends on what pattern you would like to use, but it's the same way you would basically do in any first in first out queue. It's, you just dump the message and then have a listener pick it up. Okay, I have
Okay.
no idea as to why this is not working, because the task web
Still.
service seems to resolve itself. The others are not, but all of them are running on the same URL. So, okay. Uh,
Okay. I'll move on to the next question.
sure. I'll try to get
Uh,
this to work, but if not, we'll just at least let's get the answers in by that time.
yeah. So, next question is, while designing microservices, can we
Mhm.
combine core domain and technical domain in one microservice based on our requirement?
No, you shouldn't, because by definition, the whole tenet of a distributed design is to kind of ensure uh, that you have a good separation of concern. So if you merge them together, your separation of concern is lost. You're losing that basic tenet of microservices there. So don't do that. Keep it as much based on the business domains and all. Keep it as much flexible as you can, right? And or segregate it out, and then uh, just ensure that you are. Give me a minute, okay?
Anil,
Yeah.
Praveen here is suggesting something. He's
Okay.
asking you to say use V2 API docs API and get the data. Load into editor.swagger.
Yeah, we could do that, but then I will not be able to pass my authorization header. So that's the challenge. If I, even if I go to, let's say, slash user auth v2, yeah, because it's basically forwarding it from the web service registry, from the, sorry, API gateway.
Okay.
Yeah, it's internally when it's basically when I'm relaying this to that service, what's happening is somehow the Zool client is connecting out here, which it shouldn't, because we just have one. So if you look into the API gateway, basically fails, saying that I cannot. It's going to kind of time out after some time. But this is what happens. It basically is, that connect is timing out, and this same connect is working fine for the task service. Yep, see here.
Hmm.
So the task service went out well. So it seems to be some networking problem that's there on my Mac. I don't know if some port thing or something, but for these two services, I'm not able to move forward. So if I kind of
Okay,
take
I
the
think
task, but it won't just work because I don't have the token setup. That would be to set up by the authorization server. Sorry, folks. I think, like I said, I don't have time. I'll probably get this to work and then just ping share so that you can just let everybody know. But again, this code is there on GitHub, so you guys should be able to kind of run it and then take that forward. Yeah, Pooja, go ahead.
yeah. So let's take the questions. Meanwhile, so I guess the previous questions was done, right? Anjali, I hope your question was answered. Moving on to the next question. Can any microservice architecture system exist without using Docker, Kubernetes, and any cloud?
It can, but it's not much useful because you'll have to do everything by hand. Like if you see on my local desktop, that's what I did. I kind of started everything by hand. But if you really want it, right? So I could run all of this through Docker also on my local machine, and we'll try that out also. Yeah. So, but it's not useful because then you have to do everything on hand, which is by hand, which is not the right way to do it. Okay. Kapuja, go ahead.
Yeah. Next question. When in event-driven architecture, do we really need orchestration?
In an event-driven architecture, you basically are doing orchestration by passing your events. That's your events, right? Now, if you really want, if I'm assuming you are talking about the saga pattern for to me, right? And then if that is the case, right, your sagas could again be event-driven, right? And instead of kind of having an orchestrator, you could do it both ways, but then you could emit events that lets your saga kind of do either a rollback or roll forward or move forward. So yes, in both the cases, you would need that.
Okay. Next question.
Good.
Just a minute. There are two parts of this question. Rahul has asked part one. He's saying my project is currently not having JPA for DB operation using JPA repository. All the
Mhm.
DB operations are done using Spring JDBC, like simple JDBC insert, simple JDBC call, etc. This is
Okay.
the part one. And then part two is I want to migrate this design to JPA. Is it necessary and also easy? That's a question. Second question is I want to modularize the project and make it microservices from monolithic. Is it necessary?
Okay. Not necessary. Like I said, it depends on what you are doing, right? So the first part of JDBC to JPA, it depends. If you really see, JDBC gives you a more fine-grained control. So as you as you look into doing letting the framework do a lot of things for you, you lose out on the fine-grained control, right? So if you kind of have your JDBC repository, you get a fine-grained control on how you want to execute your queries and all of that. Once you move to JPA, you give that control to the framework and assume that the framework will do a good job of that. So it depends. I kind of, if you really want to start, let's say, if you want to convert, you should. For most of your basic use cases, JPA would work fantastic, right? But for specific cases wherein you need a really high performant database call, or you want to tell that query how to do an index and all of that, right? That's where you would need to use a JDBC repository. So it's a in general, for most 90% of the things, the framework will do a good job for you. But then you would have to kind of then go into nitty gritties and then solve specific problems if you get into run into any issues. So absolutely, if you move from JDBC to JPA, it's going to give you a lot of ease in terms of how you write things, right? All of it comes with the frameworks. There's a lot of benefits to that, but just be aware that that comes at the cost that you don't know what's going on internally, right? So you will have to, that's something you'll have to kind of be aware of, right? The second part of monolith to microservices, kind of I said that when microservices is a overblown buzzword, right? But it also comes with its a lot of cost, right? A lot of cost in terms of basically uh, uh, in terms of handling or doing all of these patterns where your distributed system comes into picture and they work well. So if you really have a monolith that is working out well, right, and that is not giving you any trouble, I would say stick with the monolith. Just modularize it well so that you have a good layered design and all of your modules are separated out. That's a good way if you don't anticipate a lot of problems. You have a smaller application that doesn't need, but if you really have an application that needs, let's say, 100 and 150 people to work together, then definitely yes, you should move from monolith to your microservices. I hope that kind of answered the question.
Okay.
Okay.
Next question. Can you please explain how authentication and authorization is handled in Gateway?
Okay, I'll just walk you through the code. Give me a minute while I kind of try to see if I can get my Docker to work on this. Are you guys able to see my screen? Is that still visible?
It is visible, but
Okay.
it's static right now. Is it that you're not moving it? Look, it's
No, I'm doing something, but maybe I don't know if I have not shared it. So I'll go back to sharing my whole
no,
screen.
no, it's
Okay.
moving now. It's moving now. Yeah. It's
Okay. All
moving.
right.
I thought yeah.
So, okay. So I believe what was the question again, Pooja? Sorry, I just was flipping too many things.
Yeah, it says, please explain how authentication and authorization is handled in Gateway.
Okay. So if you look into this gateway, I'm going to try to. So within this specific example, what we've tried to do is we've tried to basically have an OAuth2 and then use a JWT token. So if I go back and we start looking into my gateway configuration, and we'll go back to configuration just to show you how that works, right? So my authorization server basically creates uh, I mean, it's in the application, but it basically creates a JWT token using a client server certificate, right? And that client certificate is with the JPA layer, but then the public certificate is with the API gateway. So when you get a JWT token, it basically looks up, right? And it can look into that public and decrypt that JWT token for me. So that is kind of where my key value defines how that basically that token gets decrypted and it's passed forward. So if we go back into the code, right, and then we Here I've kind of had Spring. Give me a minute because I'm sure this is not visible. Is the code visible now, Pooja?
It is. It is.
Okay. So I basically you define a annotation called an enable OAuth to SSO that tells my API gateway to forward that OAuth to JWT token to the corresponding service, right? So that's how we do that. So we when that OAuth token gets passed as an authorization header, the API gateway will receive it. It's able to decrypt it because we've told it what the public key is, right? And then it's able to kind of do that. And then similarly, each of those microservices can take that JWT token, and you will see that each of them correspondingly have the JWT token key value, public key here, which enables us to decrypt that JWT token and get the user's data from there. So that's how we do that. Okay.
Okay. Next question is Mayuri. I hope your question is answered. Next question is: can I implement microservices in Python with Django or Flask?
You can essentially you can. The problem with some of those frameworks is that you don't have things available out of the box, right? So like I said, a lot of those patterns like circuit breakers and all, you need to build them to be able to do good distributed system, right? So if you have a framework in Python, let's say, that enables you to do that, absolutely go ahead and do that, right? You should go ahead and do that. But if you don't have that, then you have to build it. So at least, so even within, let's say, into the Java framework, you have Word.x. Spring Cloud is probably the most mature of the microservices frameworks that is available there. But you have Word.x, you would have on the Node.js side, there's something called Sencha. There are a couple of other frameworks that are also there, right? There's a couple of them that basically compile this code that we built from Spring into, instead of doing a runtime compile a dependency injection, they do a compile time depend. I forgot the name of that framework for now, but it gives you like ultra fast startup time rather than with something like Spring Boot that takes like 18-20 seconds to start up. So it depends. But then Spring Boot is and Spring Cloud are not the only game in town. Okay, there seems to be like,
So your demo is working, Anil, or still not?
I don't think so. I'm trying to get this to work. There's some kind of a network glitch here.
Okay. We've only 12 minutes left. Just a time check.
Sure. I know. So I think this, because when I run it on Docker, what happens is my system has only a certain amount of memory, and it's going to it's not going to be stable. It will work sometimes. It will just fail off the other time.
Mhm.
So yeah, so it worked for now. So we'll just try to see. Are you guys able to see it?
I can see it. Yes.
Okay. So what I have done is I've kind of created. I've had Swagger basically relay is to each micro. So you don't need to go to each microservice. You can just call all of them right from a single Swagger API. Right. And again, like I said, it just depends. With it might start, it might not start, but we'll at least try to see. So what I'm trying to do is I'm going to get a JWT token out of it. So we'll just we'll have this. Okay. So we'll try to do an authorization, right, with a user that. So all of this information is there in the repo. There are kind of README files that tell you what to do, right? I'm going to say authorize, right? So if it's authorized, then I'll be able to get my own data, and so I get my own data to saying I'm a user, right? And I've got a token, my OAuth2 token, which is of type bearer and all of that. So if you go back and see here, right? It's not showing the current one, but if I give me a minute. And we'll
And then
try.
you're going to share the GitHub link for this?
It's already on the present. It's in the presentation, Pooja. So if we can work with
Okay.
Shreya to also put up the presentation on along with, I don't know how that works, but it's there in presentation, or we can send it out to the participants separately.
Yeah, so Suchito, to answer your question, yes, we'll share the GitHub link.
Yeah, it's a public
Um,
repo.
uh,
You
yeah.
can definitely use it and then take that forward, right? So you see here, we basically call the me endpoint, right? And then you look into header, it basically passed you an authorization token. This is our OAuth2 token that we got, and this is kind of what goes to each service, right? Now I just hope that my task service is up. Yes. Okay, great. So if I now kind of make a call to task service, it's going to give me all the tasks, right? And then I can go and kind of get a specific task. It would give me the comments under the task. Okay. Okay, and then it kind of gives you the comment task. So this is default comment, which means my comment web service is down. That's why my circuit breaker has kicked in, and it's giving to give me default comments with a default date. And you could do it differently, but this is where your circuit breaker is now in place. You're getting default comments. So if you take up uh, this commands, then all of them, yeah, like I said, my task service. So this just happens because I have like 16 gigs of RAM on my Mac, and then Docker kind of consumes all of it. So it just basically will kill the services and they'll come back up, right? So sometime it works, sometime it doesn't. That's why I was trying to go more with the Java route, but there seems to be like a network issue there. Okay, so let's see if this works again. But I think you got. I mean, I at least I'm able to get to like 60% of the demo that I wanted to show. So this is actually good. Okay, so this is a default comment. So if we go back and look into the comments web service, I believe it should be probably restarting. Yeah, they just restart because we don't have enough memory.
Okay, I think it's good, Anil. Let's take there one or two more questions.
That's good. Like I said, I'll just look into this. We'll continue answering the questions as we move along.
Yeah, yeah. So next question is it necessary to have database per microservice, or can we stick for one database, which is the best practice?
Best practice is the ideal state. Your nirvana is if you have a database per service. That's your ideal state that you should go for, because as soon as you have a shared database, then you are going to again step on each other's shoes. Because if I want to make a change to a schema that you might be using, then you will be again tightly coupled. So if you really want to do that, you should really go ahead and then have a different databases for each of your services. Okay, I
Okay.
think so. This also works. So just 1 minute, Pooja. So now you guys see that. So we got task for a specific, sorry, comments for a specific task. So this is not again the default. So this is without the circuit breaker. If your application service goes down, right, and it will happen in sometime eventually. We saw the default comment for this, right? So that's kind of where the circuit breaker kicked in, and it basically sent you the default data. So I'll just kind of also try to see if I can show you how that kind of gets enabled. While I do that, Pooja, let's take up the next question.
Okay. Is Spring Boot intended for building microservices?
No, Spring Boot is an opinionated framework to build Spring services or to kind of use Spring. Spring Cloud is what basically gives you the ability to run it in as microservices.
Okay. Next part of this question is, can we use Spring Boot for building traditional web applications?
Yeah, absolutely.
Okay. Next question. My lap is 8 GB and it's Windows. So how should I set up dev environment? Dev environment.
So it depends. Do you really need all the services? You might not, right? And then you could have your services shared across, let's say, a set of developers also. So it depends. So if you really look into that, and if you have really well packaged JVM services, you might need like a 500 KB, sorry, 512 MB to run a microservice, and that's good enough, right? But if not, then you should only run your own services. But then for all the dependencies, use shared instances, right? You could use shared instances to basically push your, let's say, your services and get them registered. So some of it, your configuration server could be running at a common place, right? So you will have to look into that and say, how do I get this to work, right? But 8 gigs is reasonably okay for running whatever I had to kind of show you, right? Because some of the common services really need a fairly less amount of memory, right? It's actually your services that might need more, and you can just run it one at a time.
Okay, that's it, Anil. We don't have any more questions. Is there anything
Okay.
else that you want to share?
So I just wanted to kind of show the circuit breaker pattern for people, right? So we use Hystrix as a circuit breaker here. So you basically say that if I'm going to call this method, which is get comments of task, and if it fails, I'm telling it, go to this method and then give me the output from there. So if this fails, right, which it would, then it basically returns you the default command, like I showed you, right? So sometimes before we saw the default. So this is how the circuit breaker pattern works. So what you're really telling it, you basically, with this REST template, I'm saying, go to the comment web service, get comment specific for this task, and if this fails, then automatically the circuit breaker kicks in and it will basically return data from this method. So that's how the circuit breaker pattern. So I just wanted to show it also to you because with the if you were running that on through a Java manager, I could have explicitly shown you, but with running it on Docker, specifically on Kubernetes, I cannot just show that to you very easily. Okay, uh, that's it.
There's
That's
two
it
more
from my
questions,
side.
Anil.
Sure.
Just quickly, I'll take up. I think that will be the last two questions for today. First is, what tool is used to generate OAuth 2 token for your demo?
I use an OAuth 2 server. So I've set up an OAuth 2 server that basically, so when we basically call the authorize button that you saw, it makes a call to the OAuth 2 server, and then it generates a token based on whether the request gets authenticated. So take a look into the code. If you have any questions, do let me know, ping me on my email, and I'll be glad to kind of assist you on that. But we use you kind of, if you look into that repository, there's a separate repository called auth server that basically runs the OAuth 2 server.
Okay. Last question, recommendation for front-end framework for Spring Boot.
You could use any framework you like. If you use any single page framework, you see, essentially you are consuming APIs when you build your microservices, right? So if you take in any good, well architectured single page framework like React or Angular or Vue, all of this will work really well with any microservices and Spring Boot.
Okay, we have one more question come up, and Vaibhav, I hope this will be the last question for the day. We are really running out of the time, but I'll still take up your question. What will be the best way to communicate between microservices, gRPC, or REST call?
So it depends. Like I said, again, it depends on specific use cases. If you really want to kind of have a synchronous call, obviously you do REST calls. You could do an event-driven calls using something like Kafka, gRPC if you need to. So it depends on the use cases, and there's no definite answer to that, right? But for anything that can wait and can be eventually consistent, right? So if you look into the CAP theorem, right, which basically says of the consistency, availability, and network partition, only two can be satisfied, right? So when you basically go with the distributed system, you kind of inherently say my focus is going to be on availability and network partition so that my services are not down, they're always up, and then consistency is I'll achieve by with an eventual consistent model, right? So that is where, if you really are doing at scale distributed system, you should go with an eventually consistent model with an async mechanism like event-driven mechanism like Kafka, or you could use gRPC if you want to kind of call, make that call over there. Not so familiar with gRPC, but if you use any streaming mechanism like Avro and kind of use that to pass streams, that is there. But you basically have to make a call on whether I want to use an asynchronous communication or I want to use an async communication, and that's what should drive your choice of inter-service communication methodology or tool set.
Thank you so much, Anil. People are asking for your mail ID. Shreya, I guess you can post all these on the Skillenza platform. People can,
Yes.
I'm sure all these people can take it from there. I will just quickly wind up this session for today. I'm really overwhelmed and happy to see all the questions and the interest people had. And thank you, Anil, for the non-stop
My
and
pleasure.
high
Yeah.
energy power pack session. Really appreciate all your time and all your answers. I hope people got their answers, and they if they have any other queries, as Anil said, you can reach out to him anytime. I'll just quickly go through, take 2 minutes to take you through what Altimetrik is. I won't go through the details, just tell you that we at Altimetrik is a 2,500 plus people's company. We're a team of 2,500 professionals. We operate in the areas of retail, consumer supply chain, banking, financial services, payments, fintech, healthcare, pharma, manufacturing, and automotive. We are there. We are servicing in more than 15 countries. You can take a look at our key customers. Uh, the good part, which I am very proud to announce, and we all take a deep pride in that, is all the certifications and awards we have received, not only from all these, or from Gartner and NASSCOMs of the world, but we have been ranked 48 by Great Place as Great Place to Work, a fourth time in a row, and the top 25 in the IT and IT industry, and we are the and amongst top 100, India's top 100 safe place, best workplace for women. So Altimetrik has got a great work culture. I would really request all of you. There's an email ID and a link on the screen. Do drop in your resumes if you wish to. There's an email ID and there's a link as well which you can connect to. So we great power packed 1.5 hour session. Thank you all for joining us today. Thank you, Shreya, and
Thanks a
thank
lot,
you.
and thanks to all the participants for all the questions. It was a really interactive session, so definitely thanks to that to everyone.
Great. Thanks a ton. Stay connected, guys, all of you.
Thanks. Bye bye.
Bye.